So I hope you understood from the examples a little more on how permutations work. Now let us look at a special case. That is, suppose we have identical elements. That means, what does identical elements mean? Suppose we have same number of elements. Sir, how does that affect it? Let us see. So now we are going to look at special cases. So special case number 1, when there are identical elements, and that is, for example, Raja. So see, I have put each letters in different colors because to make you understand, okay? Just to make you understand that I put each letter in different colors. Okay. Now this is the spelling of Raja, R-A-J. It is, right? I hope it is. I mean, I think it is. Okay. Anyways, if I interchange the A's, if I just shift the A's, if I put this A there and if I put this A here, it will be Raja. Oh wait, it's the same thing. It's just the same thing. It's just the same thing, right? I interchange the A's, so it's another permutation. Right, these are two different permutations. But guys, remember permutation has an order. And so if I give you 4 letters, if I give you R, A, J, A, okay, 3 letters basically. If I give you R, A, okay, four alphabets, okay, R, A, J. If I give you 4 alphabets, and if I tell you, please, find different ways of writing, arranging 4 alphabets. This is one way you can arrange them, right? If I give you R, A, J, A, there are different ways of arranging them. One way is Raja, another way you can also write a Jara. I'm sorry, Raja, but it is another way of writing it, So different things, and these are different possibilities. So these are some of the different possibilities, and why I wanted to show you is this possibility number 1 is not equal to number 2. It is not. According to permutation, order is very important, and therefore in our NPK formula, this will come as two different things, but in practical purposes, it is of no use. I mean, this is not of any use. I mean, if you just shift the A's, it doesn't change, right? It doesn't change. So for example, Jara, if I take Jara and if I interchange the A's, it becomes, it still looks Jara. It is not going to change. But actually there is a change. The alphabets are interchanged, but there is no visible change. So you see that every possibility that you take, everything that you take, there will be a copy of it, because there's only 2 identical elements, A. So there will be a copy of it. There will be twice. It will be twice the number of what you actually need, right? So you are overcounting. So when we use NPK formula, we are actually overcounting. So if we have 4 letters, if we have 4 alphabets, how many ways you can arrange them in 4? I mean, the total number of alphabets is 4, and total number of options is also 4. So the permitted NPK is 4p4. Now 4p4 is 4 factorial divided by n minus k, that is 4 minus 4 factorial, which is 4 factorial divided by 0 factorial, which is 4 factorial into 0 factorial is 1, right? So it will be 4 factorial is equal to 4 into 3 into 2 into 1. That the answer is 24. But this 24 is actually an overcounted number. Why? Because 24 is actually has twice the number of what you actually need. For example, this is one combination, Raja. You have a copy of it. This is another combination, Jara. You have a copy of it. Now if you put Ajra, again you will have a copy of it when you interchange the A. So every possibility you will have a copy of it. So you need to divide this number. This 24 is too much. It is 24 is actually double the number that we need. So let us divide by 2, because we have twice the number of whatever we need. So let us divide by 2 and we get 12. And this is actually the number of four letter name that we can make with the alphabets R A J A, 12. Now from this, let me take you to another example. So by the way, being identical elements are sometimes pretty important. For example, identical twins. If there are twins in a competition, you cannot just cancel out one and put one. It is pretty important that both are two different people, right? But in that cases, the identity is different. Even though they appear the same, the identity is different when each person is unique. And sometimes there might be cases where we have to use identical elements. Sometimes, like in the case of the name Raja, it doesn't matter if we change the A because it looks the same. So there are different types of cases. You need to look at each case. So as I said in the beginning, arrangement depends on each situation. Look at the situation, understand the situation, and then deal with it. Now, suppose I take the name Bandana. This is in permutations. This is a difficult name. Why? Because there are two A's, there are two N's, and okay. Sorry, there are three A's. There are three A's and there are two N's. Now, if I interchange these two A's, I will get Bandhana itself. Even if I interchange these two A's, I will again get Bandhana itself. So you see now the number of copies are increasing. So what decides the number of copies? That is what we need to see. Now, not only the A's, if I change the N, what happens? If I interchange the N, it will become again Bandhana. So, and if I interchange the N's again, and if I put a different order, it becomes Nabdhana. Now, in this order also, if I interchange the A's and if I interchange the N, it will just keep going on. You see, every possibility will have different copies of itself, and that is too much overcounting. It is overcounting a lot, and I don't need that. It is a waste of counting, I would say. So how to solve this issue? So let us go in a progressive manner. There are 7 letters. 1, 2, 3, 4, 5, 6, 7. 7 letters and 7 ways of arranging. 7 options. Bandhana's name only has 7 options, and there are 7 letters given to you. So it is 7p7. That is 7 factorial divided by 7 minus 7 factorial, which is 7 factorial divided by 0 factorial, and that is 7 factorial itself. 7 factorial divided by 1. But as I told you, this is an overcounting, so I need to divide this by some number. And how to find that number? That's what we need to see. So 7 factorial divided by, let us see what number we need to get. So there are 3 A's, we saw that there are 3 A's in her name, and these 3 A's we can arrange it in 3p3 form. That is 3 ways of arrange 3 options, and total number of letters are 3. So 3p3 forms. 3 factorial. 3p3 is 3 factorial divided by 0 factorial, that is 3 factorial. Now not only that, the repeating letters are not only A, there are N also. 2 N's in her name. So it will become 2p2 arrangements. 2 factorial. So we see that when we interchange the A's, we get 3 factorial copies of the same thing, and when we interchange the N's, we get 2 factorial copies of the same thing. You get it? So now let us see what we should divide it with. So because of the a, we have to divide it by 3 factorial, and because of the n, we need to divide it by 2 factorial. So 7 factorial divided by 3 factorial into 2 factorial gives us 76 into 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial. 3 factorial, 3 factorial gets cut, and solving it, it becomes 420. Now, how did we get this? Again, because of permutations. So when we have identical elements, we have to divide by that, so that we will not get identical values. Because if I have 4 bandhanas like this, it is not actually, there are more possibilities. I have already written 4. It will not be of any use, right? I mean, because suppose I'm writing a roll list, or if I'm making a roll number, if you see 4 bandhanas or 5, 6 times, if I write bandhana, what's the point? What is the use? Bandhana is one person, and the name only has to appear once. So what I'm trying to say is, we need to avoid identical elements. We need to avoid overcounting. So this is what we do to avoid that. Now, so this is one. So let us come back to our previous example. We studied about Raja, and we saw that we divided by 2. Now again, this 2 is not a magical number. So suddenly I came up with Raja has 2 A's, and 2 A's can be arranged in 2p2 ways. 2p2 is 2 factorial. So this 24 by 2 is actually 2 factorial, but the answer of 2 factorial is 2 into 1, 2. So it was just coincidence, that 2 factorial became 2. That is why the answer didn't change. Answer was 12 itself. So actually what we divided by 2 is actually 2 factorial. Okay. Now, so that was special case number 1. Now let us go to special case. I know there's a lot of things happening, I'm telling you a lot of things. Please go through it slowly. Even I am finding it difficult to put everything into your head, because I know how difficult it can be. But one thing I will tell you is, please go through this, and if you feel that you are not able to understand, ask me, and I will make something else. I'll make some other video, or I will try to explain in some other way or more detailed way for the person who asks, because not everyone, some people might be able to understand, some might not be able to understand. It depends. Some people have already studied, or might have already gone through the chapter. Some people have not. So it depends on each person, and it also depends on the mathematical foundation of each person. So if you don't understand, just let me know. I will try my best to help you out by the grace that God gives me. Okay. So special case number 2. When you want completely different things, okay, and you don't care about the order. See, first of all, permutations is about order, and saying that you don't care about order is actually blasphemy. but suppose you want completely different things. For example, okay, let us look at an example. Oh, again the name Raja comes up. Raja. Now I can write it as Jara, and I can write it as Ajra, and I can keep writing it like that. But suppose you say that, oh no, I don't want you this repeating things. Oh, come on, what is the difference? Raja, you same letters. I want different things. For example, I want B, C, K, W, all these letters to come. That means, if you want, see, in this case, it is just rearranging of the elements here. Raja, I'm just jumbling up the letters, and I get Jara and I get Ajra. So this is important, because in permutations order is important. But suppose you're saying, sir, I don't want this, I want different things, different alphabets, different things. I don't want it all. I don't want anything to be the same. I want completely different things. Then we need to go for a different one. That is, this is just a I want a combination of different combinations of different letters. Yes, it is combination, the word combination, exactly. That is what we are going to study next. The next class we'll study about combinations. So see you all in the next class.